Alright, the next equation we have y equals negative 1/2 x plus 1.5. So our slope here is negative 1/2 and y-intercept is 0, 1.5. Okay, so yeah, that's the y-intercept. So if we're going to graph this, okay, all right, yeah, you will graph this, so you assign values for your x, or you can graph this based on your slope. So when x is 0, y is 1.5, and when x is, okay, we can say to 1. Okay, let's just say your x is 3, so it'll be 0. So this is 1, 2, so 1.5 is here. When x is 3, 1, 2, 3. Okay, so your graph would look like this. All right. Yeah. Yes. Yeah, if your x is 0, then you plug it in here to your equation. You substitute x there, so you get 1.5. If you substitute 3 there, you have negative 3 over 2. Yeah. Alright, so we go to the next one. Okay, so we have solved the following systems of equations and state the solution. So we're given here two equations. Y equals negative 3/4 x plus 4, and the other one is y equals 1/2 x minus 1. So the slope of the first one is negative 3 over 4, and the other one is positive 1/2. So let's graph this. Still, okay, the first one we can assign values for the first equation. Let's say when x is 0, y is 4. 2, 3, 4. Okay. When x is 4, y is 1. 1, 2, 3, 4. So this is 1. Okay, so this is the graph of the first equation. Yeah. Oh. So this is the graph of y equals negative 3/4 x plus 4. Okay, let's graph the second one. This one, y equals 1/2. So the slope here is 1/2, and the y-intercept is 0, negative 1. So we can assign values for x to solve for y. Let's say when x is 0, y is equal to negative 1. So this is negative 1. Then when x is 2, so that is y is 0. Okay, so the graph would look like this for the second one. Let me change that to red. Yeah, this is the graph of y equals 1/2 f. You get your calculator. But we were not, when I was still in the university or in high school, we were not allowed to use that, because that one is very easy, and then you won't be able to know how to solve this one, how to graph manually. So, do you have your calculator? Yeah, can you show me? What is that, Texas? What are you using, Texas? The brand. Yeah, it's Texas. Yeah, can you show me that? Because it's not common here, and I really wanted to have one Texas Instrument calculator, but then I can't find it here. So this is the point where they intersect. All right, so the solution of this one, so this is the solution for 1, the point where they intersect, x equals 4, y equals 4. So we solved it graphically, but you can also solve this by substitution or elimination. It depends on the given. In this case, you're given 2 equations, and you need to solve for yeah, because you're given 2 equations. Yes. Oh, we're done with this one. Can we move on to the next problem? All right. Okay, so the next one, we're given these equations. 2y minus 5x equals negative 8, and the other one is y plus x equals 3. So let's rewrite this in the slope-intercept form. So this is 2y equals 5x minus 8. Then we divide both sides by 2. So y is equal to 5 halves x minus 8. So the slope here is 5 over 2. And then the other equation is y equals negative x plus 3. So the slope is negative 1. So let's graph this. Let's graph each of the equations. So for the first one, no, 2y minus 5x equals negative 8. So here we can assign values for x. Oh. Yeah, we'll see if you get the same graph, okay, using your calculator. So when x is 0, here y is negative 4. No, negative 8. Oh. No, negative 4. For a while. I think I made a mistake here. It should be, because this is 8. 8 divided by 2 is 4. So this is negative 4. So when x is 0, y is negative 4. So, and then when x is 2, y is 1. So this is 1. So this is the graph of the first line. Okay. See, this is blue. Okay, this is the graph of the first line. 2y minus 5x equals negative 8. And now let's graph the other one. Okay, graphing the second one with the slope negative 1. Let's assign values for x to solve for y. So if x is 0 here, y is 3. So this is 3. Then when x is 1, okay, negative 1, y is 2. So when x is 1, y is 2 here. So the graph would look like this for the second line. So this one is the graph of y plus x equals 3. This one is the point of intersection. This one, let me change the color. This one in blue, this one is the point of intersection. So this is the solution to a system of equations. So this is point 2, 1. X is equal to 2, y equals 1. Yeah, you got that? Did you understand that? Okay, we graphed because we were asked to solve the system of equations graphically, so we graphed each one of them, and the point of intersection, that one is the solution to the system of equations. But you can also solve this using substitution and elimination. I don't know if you already had that lesson. No. If you're given two equations, like in this case, the solution is the point of intersection where the two graphs intersect. So yeah. But if you're only given one equation, so of course the solution is like any points on the line. Oh, all of the points on the line. Okay, so let's move on to the next one. Yeah, so we're graphically solve the system. So we're given here two equations, 2x plus 4y equals 24, then 3x plus 2y equals 19. We need to write this in slope-intercept form. 4y equals negative 2x plus 24. Divide 4. So y here is negative 1/2 x plus 24 divided by 4 is 6. And then here 2y equals negative 3x plus 19. Divide by 2. So y is equal to negative 3/2 x plus 19 over 2. So the slope here for the first equation is negative 1/2, and the slope here is negative 3/2. And now we can graph each one of them. Blue. Alright. Okay, let's graph the first one, the first equation first. Let's assign values for x to solve for y. So let's say x is 0. When x is 0, y is 6. So 1, 2, 3, 4, 5, 6. Okay, so when x is 2, y is 5. So 1, 2, so y is 5 here. So the graph would look like this for the first equation. Just use red here. So this is the graph of this one. 2x plus 4y equals 24. So that is the graph. Now we graph the second. Okay, for the second equation, the slope is negative 3/2. So let's assign values for x here to graph this, to solve for y. So when x is 0, y is 19 over 2. So what is 19 over 2? 9.5, right? So when x is 0, oh, it's somewhere there. 7, 8, 6, 7. So we will extend our graph. 8, 9.5 is somewhere here. Here. So this is 9, 9.5. Then okay, I'll just use yellow. So here 9.5. Then when x is 3, -3 halves 2, -3. Oh, let's just do 19 over 3. So it'll be easier. 19 over 3, so that would cancel out. Then you have 19 over 2, so 0. So when it's 19 over 3, what is 19 over, say, 3, 4, 5, 6? Huh? Number 3. Number 3, graphically solve the system. So it's 6.3 here. So the graph would look like this. So it should intersect the, it's not accurate, okay? So it should intersect here. So let's say if you use a graphing paper, if you use a graphing paper, it will be better. It will be accurate. So the point where they intersect, that one is the solution to the system. Yeah. Yeah. I'm sure. But you'd better use the graphing paper. So this one, this point, it should be like okay, it shouldn't intersect there, somewhere there. Let me check. It should be here. 17, somewhere here. Okay, like somewhere here, not exact point. So this point is 7 over 2, 17 over 4. Let's try number 4. This is a word problem. I meant mathematical sentence, and you have to write this as a mathematical equation. So, given y is less than 3 times. So is less than 3 times x. So that should be, the equation is like that. Y is 8 less than 3 times x, and the other one is y is also 3 subtracted from half of x. So that is half of x minus 3. So you should know how to write an equation from a mathematical equation from a mathematical sentence. So the slope here is 3, and the slope here is 1/2. Then we graph them. Y equals 3x minus 8. So we graph this. You just have to make sure that, you interpreted the problem accurately, and you wrote your equation accurately. So the slope here is 3. So we assign values for x to solve for y. So let's say our x is 0, then y is -8. So 1, 2, 3, 4, 5, 6, 7, 8. So this is -8. Then when x is 1, 3 minus 8 is -5. Y is -5. This is -5. Yeah. So our graph would look like this. Okay, so this is the graph of y equals 3x minus 8. Then we graph the other one. So we graph the other one with slope 1/2. So we assign values for x. When x is 0, y is -3. When x is 2, y is -2. Okay, So when x is 0, y is negative 3. When x is 2, y is negative 2 here. If you're given like this, like only the word problem, oh no, the mathematical sentences, you need to know how to interpret them or write them in mathematical equations before solving them. Yeah? Yeah, you should know how to do that. The solution here is where they intersect. So where do they intersect? They should intersect here, 2, negative 2. So the point of intersection should be 2, negative 2. This is the solution. I think you'd better graph this in a graphing paper so it will be accurate. Because it's here. It's not accurate here. Because I just drew it. I just estimated. Okay, so do you have questions on this? For number 5 is the same. Yes. If you're given a mathematical sentence, you need to know how to interpret and write that into a mathematical equation. Yeah. Can we move on to number 5 so I can show you? Yeah. Let me delete this. Okay, for number 5, given the sum of x and y is 5. So it says sum, so you add sum of x and y. So add y is 5, so equal to 5. And the difference of x and 1/3 of y. So x minus 1/3 of y is 1. So that's how you write that. And then you write this in slope-intercept form. So this is y equals negative x plus 5, where the slope is equal to negative 1. And then this one, negative 1/3 y equals negative x plus 1. You divide both sides by negative 1/3. Yeah. Then this equation would become 3x minus 3. Yeah. Now let's graph. Again, this may not be accurate. I mean the graph, because I'm only like drawing it here. Okay, now let's assign values for x to solve for y. So for 0, x0, y is 5. 1, 2, 3, 4, 5. When x is 1, y is 4. This is 4, so here. So the graph would look like this. Hey, are you alright? So this is the graph of x plus y equals 5. So the second one, we assign values for x to solve for y. So when x is 0, y is negative 3. 1, 2, 3. Okay. When x is 1, y is 0. So here. So this is the graph of the second line. Change that to blue. Alright. Now the point of intersection here, it should be this one. 2, 3. So this should be 2, 3. So the solution to this equation, system of equations, is 2, 3. X equals 2, y equals 3. Alright? No questions on this, Tina? Yeah, we can. Yeah, can we go to that? What's that? Volunteer or something. All right. Okay.